Dear colleagues, welcome to the final lecture presentation done for the Meaning Project and final conference. Before I start this lecture, I would like to say the following. While our world is facing very serious challenges requiring strict energy use, control, and development of innovation ideas and technologies to support the strict regime, we cannot ignore the positive research and innovation tendency in ICT development cluster. Inspiration and novelty, these are key issues for most of the ongoing research activities of the last decade. To take advantages of these innovations, it is necessary to evaluate those challenges we face and those innovative methodologies in research and technology development which intended to deal with these challenges. So today in this lecture, which is titled as Empowering Research with Use of ICT for Better Energy Efficiency, I will talk you through the process of selection and categorization of those RTDs, areas related to ICT-enabled research for energy efficiency activities done on the worldwide scale during the last 10 years. This will help you to select your own research areas, to progress with your research activities, and to be successful in this way. At the end, I will talk you through the updated projected vision on related research areas, where we will see incentives and barriers on this road to successful research. First of all, we have to say that ICT has been identified as one of those possible means to design, optimize, regulate, and control energy use within existing and future production. We can see in real time right now that it is promoted that full exploitation of the opportunities offered by ICT for energy efficiency requiring adjustments of various industrial processes and related contractual practices in business sector. So research is developing and industry is picking up from there or participating in research in order to gather latest and greatest achievements of those researchers. So the core is a transformation of focus from the initial production costs to a whole life performance of the end products. This means the value to owners of the products, especially with regards to energy performance. So starting or initiating the researchers, research projects and activities, we have to keep in mind those ICT-enabled research objectives. So here you can see that the objective one I'm mentioning here is to set up the national and international research communities, which means bringing together actors from the ICT, energy, and industrial sector. This is to provide with a comprehensive set of stakeholders for discussion and feedback to vision and to keep in mind the research roadmap. It is also important to identify current best practices in RTD and related project results. So key examples of those projects and initiatives in the field of ICT for energy efficiency will be your guidance of how to achieve the best possible results and related outcomes. This is to provide the reference basis for identification of the state-of-the-art achievements to build the future research, vision, and related roadmap. Also, while doing the research, it is important to achieve dissemination, training, and education practices. This is to perform specific educational programs as we do here in Meaning, for example. This is e-learning lecture courses in ICT supporting sustainability for industries, for example, and so on. We have to provide awareness to future industrial stakeholders. What are we doing? How are we doing those research? And what is the possible outcomes which will benefit to industry? So, to set up the research vision, I am presenting this slide, which is based initially on so-called REAB research development process. The REAB was the project where I was personally participating and playing the key role in selecting and categorizing the research activities on a worldwide scale. So that was called a roadmap to energy efficiency in buildings. As you probably know, that UCC and IRUS group here is playing an active role in researches related to energy efficiency in buildings. So I'm using this construction sector as an example, but you have to keep in mind that for this presentation especially, I was making sure while compiling this presentation that the information I'm presenting is generally applicable for various related areas of research. So the aim was to identify the current state of research best practices and provide a vision in form of strategic research roadmap agenda with supporting implementation recommendation for ICT in research for energy efficiency in construction. So as you can see here on the slide, there are 5 research priority areas is outlined. From them, we will go to detailed specification and categorization being done with later covered subvision, drivers, barriers, impacts, key business scenarios, and short, medium, and long-term priorities. So in the center, that was outlined, let's say, the initial core bubble where platforms and technologies for energy information sharing is presented. Different areas included which are contributing into this activity, starting from energy management and trading, intelligent and integrated control, integrated production management, applications for integrated energy efficient design. Each of those sub areas is supported by so-called industry view. So for energy management and trading, it is important to collaborate with operation and services cluster of industrial service providers. Same for all others, where you can see the high performance product, industrialized production, integrated design, and life cycle performance management. They all creating this research vision, which can be taken as a beginning for the following selection and categorization, with followed up with following research vision outcomes. So before starting the specific and detailed description of those selected categories and related subcategories of possible ICT-enabled research in the area of energy efficiency and related applications, we have to mention the expected research impacts. So where those research activities should contribute to. In this context, ICT becomes an essential asset of research activities. So the convergence of technologies on one side and existing regulatory drivers on another side offers unprecedented technical and business opportunities for powerful innovations to be integrated in new products development. The related technologies especially include embedded systems, standardized and interoperable communication protocols, smart grid and internet applications, for example. So the vision today considers future product structures along with their physical components and digital environment, providing information on their status. Received data can also be sold as a product. So when we say in the research we are planning to do, or we're selecting the area of a research proposal, we have to keep in mind that research should contribute to pave the way to the ICT-enabled energy efficiency through intelligent solutions. It also should widen take-up for ICT-based energy systems and services and contribute to future energy-neutral and energy-positive systems. It should increase awareness about ICT potential, priorities, and impact in terms of energy efficiency. Research should provide us with a more holistic view on the need for integrated, complex engineering ICT systems. So keeping this in mind, now I will show you several slides with a specific information been accumulated during the development of the roadmap to energy efficiency on European and worldwide scale. Starting from this slide, I'm showing you the essence, the amalgamated vision on those areas where the ICT for energy efficiency, in this case that was energy efficient buildings, but if you will pay your attention to specifics, this is generally applicable for different ICT related products and services where the research could bring highly valuable benefits. Starting from the center, I'm showing you these 5 main categories, and each of them is subdivided into specific subcategories. So mentioning that, I have to say that in order to compile such a structure, it was a huge job being done, where more than 270 closely related projects worldwide were scanned in details, and specifically 52 of those researchers being selected for deep analysis and development of categorization criteria. That was a long way to select, to compile, to analyze, and to structurize the areas where those researchers were trying to develop some novelties in this energy efficiency domain. So the names of those 5 main classification categories were identified and consolidated at the end. The names and numbering for these 5 classification categories are as following. Starting from the top here, you can see the integrated design and production management. I'm highlighting this, right? The second one is called intelligent and integrated control. Here you can see I will not talk you through all of them. You will have a chance to read more in detail about those categories, subcategories, and related research information within the separately developed document, which I will also supply in parallel with this presentation. So for intelligent and integrated control, for example, you can see here that the quality of service, monitoring, as well as wireless networks, wireless sensor networks, automation and control, home and building system integrations. These are those subcategories where related research activities have to be further developed in order to improve those areas of products and services. The third category is user awareness and decision support. This is an area where the visualization, performance management, behavior change by real-time pricing are playing their role in improving the energy efficiency for specific products and objects. We say buildings, but as I previously mentioned, it is applicable for related areas of research activities as well, for energy efficiency in production and services, for example. So energy management and trading, as well as platforms and technologies for energy efficiency, for energy information management. All of those 5 main classification categories were selected for more detailed analysis and following conclusions and visions. I will start to talk about each single category right now with the specific details. It will not take long time, but it is necessary to outline them at least so you can see specifics. And this is in this slide. So starting from the top, this category includes research and technology development, focusing on advanced design, support tools, and design integration. You can see it here on the top. It is including requirement analysis, configuration management, CAD, and visualization. So talking about design with use of information communication technologies, it is obvious that benefits of the research in this area will greatly support the effective and efficient processes and services. The second subcategory here includes design integration with related subcategories here. Knowledge sharing, production management, simulation, and modeling. Second main classification category is called intelligent and integrated control. Here you can see those second level categories and followed up subcategories of research activities being selected and analyzed. In general, this category contains those researches focusing on the development and implementation of meshed, self-adaptive, and easy-to-install sensor networks, for example, hardware and software, operating systems and protocols, as well as development of automation and control technologies, improved diagnostics, performance data analysis, smart metering and actuation, intelligent and predictive control systems, so on. The third main classification category of selected researchers called user awareness and decision support. So the research activities which have been selected within this category, focusing on improved analysis of energy performance data and visualization of this data for better management and assessment. As you can see here, there are three subcategories called behavioral change by real-time pricing, visualization, and performance management. Fourth main classification category being outlined is called energy management and trading. So this category includes researches of methodologies and tools for efficient energy management on all levels, from urban to district, grid, building, room, area. You can see that each of those subcategories are divided for detailed specification of research activities in this sub-area. For example, so distributed generation and demand response is divided for such an areas like more effective load balancing techniques, performance analysis and evaluation, low latency communication, demand response capabilities. Last but not least, category of the research in area for research in ICT for energy efficiency is called platforms and technologies for energy information management. In this case, we could say that those researchers grouped under this category are describing specific knowledge gathering which helps to develop the technological layers for the infrastructure in both directions, hardware and software, which support the acquisition, transmission, exchange, storage, retrieval, and presentation of energy performance data. So we can consider this category as a composition of technological subcategories or layers. Additionally, we could consider research and development activities to provide specific tools which have to support the design and installation of wireless sensors, meters, and actuators networks. If you will look closer here, you can see that system integration layer, application layer, data model layer, and platform layer being specified here, where the platforms and technologies for energy information management been splitted in two different activities where research is analyzing collaborative support and interoperability, but each of them is connected to those layers or technological subcategories. As a result, vision on the future roadmap to researchers in the area of ICT for energy efficiency is applied in the specific layout where the market trends and drivers, industrial objectives and opportunities are applied on top of the time scale divided on short, medium, and long term, concluding in specific vision on those research activities where the information communication technologies research activities are contributing, together with barriers on the bottom, which shortly outlining the problems which could be met on this way. So the major challenges to overcome here are as following. This is uneven distribution of ICT for energy efficiency related research activities in different countries, as well as the number of participating entities in these countries. There are also major gaps in knowledge sharing capability in industry and research domains. Dissemination of RTD resources is not widely used. The recognition of ICT as a social technology, so it will enable such energy consumer behavior when user awareness, control feedback, and use of intelligent tools become important. It is therefore necessary that social aspects should be addressed in such areas as technology perception, acceptance, and impacts. Shortly about this vision, I would like to summarize where the short-term, medium-term, and long-term time scale is virtually dividing the status and progress of the research activities. You can see here, for example, the dynamic energy demand response in real-time working environment is the vision. That's where we have to aim, as well as software-defined behavioral change in people's energy use. And for research, I would like to mention it is desirable to have a stability in research vision in general. Now I would like to give you a short case study example, which could also be taken as a 10 recommendations for education and training in terms of meaning program approach. As objectives, the case study is presented here, is about smart meters deployment research approach. So here I'm mentioning objectives with applied information communication technologies and impact. All of this been mentioned previously in this presentation. So when we're starting, for example, the research about deployment of such smart metering technologies, we have to keep in mind that for customers, it will be a consumer awareness of real-time electricity or gas, whatever, or water consumption. For producers, the objective is better peak load management and energy network balance. For grid managers, utilities, and energy service companies, it will be better knowledge of real electricity flow or energy flow, introduce the possibility of flexible tariffs, holistic service concepts, such as energy audits and predictive maintenance. When we will select applied information communication technologies, we could say that the smart meter itself is a specific device with a simple display for some basic information to the customer, with specific and limited storage capacity, backlog, some limited common capabilities, and so on. So, as an impact of such a research, we could split that at several levels. At consumers' levels, it is reduced electricity consumption. At producers' level, it is reduction of electricity production cost through peak load management, plus some specific help to manage decentralized PV production. At grid management level, it is thousands of kilometers covered by the utility agents each year should be saved thanks to the remote online maintenance of smart meters. At this point, I would like to conclude this presentation, but I have to say at the end that ICT is a key enabler for energy efficiency-driven new business models. Synergies and cooperation between production, energy, and ICT companies will enable a new range of business models where innovative local and regional small and medium enterprises will play a key role. New business models will overcome the non-technological barriers that discourage innovation and market deployment. Future research should be integrated and harmonized with demonstration activities. It would provide to society an overall understanding how ICT can be applied to a much wider range of circumstances. Moreover, this would allow for effective and broad-scale knowledge transfer from academia to industry. We all wish you good luck and much success in your research and development activities. Thanks for your attention.